Okay, the purpose of this video is to talk about the unit circle and how you can generate it. Now, essentially, the unit circle is used for memorizing or having a way of memorizing the key values for the trig functions, sine and cosine, mostly tangent, yes. So the first thing we want to do is to figure out what the sine and cosines are for the main angles. And you can do the angles in degrees or radians. So you've got 0, you've got 30, you've got 45, 60, and 90. Or you can do it in terms of radians, which is 0. 90 degrees is pi over 2, so 45 is half of that, which is pi over 4. If you take a third of a half, pi over 2, a third of a pi over 2, you're going to get pi over 6. And twice 60 is twice 30, so that's going to be 2 pi over 6, which is pi over 3. So these are the degrees, and these are the radians. Now we're going to generate them using degrees, because it goes back to something we've learned in geometry. So there were two special cases in geometry, which is where you had a right triangle and the two sides, which is not quite drawn to scale here exactly like I wanted, so let me move this over a little bit. So what you have is a triangle where the two sides are equal. One side they're equal to 1. This is a 90-degree angle. So the Pythagorean theorem says that the hypotenuse squared is equal to the sum of the squares of the other sides, the two sides adjacent to the 90 degrees. So you get x squared equals 2, x equals the square root of 2. So this is the square root of 2. And so if I want to know what the sine of this angle, theta, now what is theta? Well, remember the sum of the angles interior to a triangle is 180 degrees, and this one's 90. So what we can say is, because these sides are equal to each other, these angles have to be the same as well. So we can say theta plus 90, which are the interior angles, equals 180 degrees. Or 2 theta, theta plus theta, you get 2 theta, subtract 90 degrees from each side, you get 2 theta equals 90, theta equals 45. So these are both 45 degrees in this special right triangle where the two sides are equal to each other. So if I want to know what the sine of 45 degrees is, it's just going to be equal to the opposite over the hypotenuse. That's the definition of the sine. And the opposite is 1, and the hypotenuse is the square root of 2. And if you rewrite this without the radical, the square root in the denominator, you multiply by the square root of 2 over the square root of 2, and you get the square root of 2 over 2. Okay, so that's the sine of 45 degrees, square root of 2 over 2. And because the cosine is the adjacent over the hypotenuse, the cosine is the same thing, square root of 2 over 2. Now, the sine of 0, if you have a 0 angle, then the opposite side goes to 0, whereas the hypotenuse stays finite, so this is 0. And likewise, if you let this theta go to 90 degrees, what's going to happen is this side is going to get really long, and so the length of the hypotenuse and the length of the opposite side are going to approach each other. If you think about that, so if you have a triangle, right triangle that looks like this, you can see how as this angle here approaches 90 degrees, the length of the opposite side and the hypotenuse approach each other, so it becomes 1. Okay, so that's the first thing we're going to do. Now the second kind of triangle that we deal with, where instead of two sides having the same length, all three sides have the same length. That's called an equilateral triangle. And if they all have the same length, then they all have the same angle. So it's kind of this symmetric triangle. And again, if the sum of the interior angles has to be equal to 180, and they're all the same, then you get 3 theta equals 180, theta equals 60 degrees. So in our equilateral triangle, each angle is 60 degrees. 60 plus 60 plus 60 is 180. Now, if you take that equilateral triangle and you take a straight line from the vertex of one side, and you can see it's not quite equilateral, so let's just make it look a little more equilateral here. So then you've got this triangle here, which is 60 degrees here, and if you cut this 60 degree in half, you're going to end up with a 60, 30, 90 degree triangle. So let's just draw that triangle in there. So we're taking half of an equilateral triangle. Okay. So this angle is 60. It's a right triangle, so this is 90. As a consequence, this other angle has to be equal to 30 degrees. And if we go back and make each one of these sides of the equilateral triangle 1 unit, then this half of this triangle, this is going to be 1, this is going to be a half, and this is going to be unknown right now. Okay, so this side is that side is 1. Since this cuts this side in half, it's a half. So what you can do is again use the Pythagorean theorem, which says 1/2 squared plus x squared equals 1 squared. 1/2 squared is 1/4. 1 squared is 1. If you subtract 1/4 from both sides, you'll get x squared is equal to 3/4, 1 minus 1/4, and you take the square root and you get the square root of 3 over 2. So that is this side, square root of 3 over 2. So as a consequence, the sign, which is the opposite, so we get the square root of 3 over 2, the sine of 60 is the square root of the opposite side over the hypotenuse. So you get the sine of 60 degrees is equal to the square root of 3 over 2. Square root of 3 over 2. And you can see that the if we go the opposite, if we go up here to 30 degrees, we can see the sine of 30 degrees is the opposite, which is a half. Opposite 30 degrees is this side, a half divided by the hypotenuse, which is 1, so you get that as 1/2. So you get 1/2. And it turns out that once you get the sign, you can just flip these around. So this 1 comes there, the 0 goes there, the square root of 3 over 2 goes there, and 1/2 goes there. And it makes sense because the 30 and 60s kind of flip each other, because this right triangle, if one angle is 90, the other has 60, the other one has to be 30. If one has 30, the other one has to be 60. So you get these values. That's kind of the starting point. Now another way to remember this without going through this thing with triangles is you take the square root of 1 over, what do I do here? Square root of 0, that's what it's, So you take the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, square root of 3 over 2, and the square root of 4 over 2. But the square root of 0 is 0, so 0 divided by half is 0. Here you get the square root of 1 over 2. The square root of 1 is 1, so you get 1 half. Here we can't do anything, so it just stays the square root of 2 over 2. Here we have the square root of 3 over 2, and the square root of 4 is 2, so you get 2 over 2, which is 1. So that's kind of a way to remember them. You just go 0, 1, 2, 3, 4. The square root of each one of those divided by 2 gives you those angles, and then, or those values, and then you can flip around to get the cosines. Okay, so once you have that, let's talk about the unit circle. So, as the name implies, and we've talked about this before, is the unit circle is a circle with a radius of 1. So what we'll do is we'll draw a circle, and the radius is 1. So this point would be 1 comma 0. This point would be 0 comma 1. This would be negative 1 comma 0. These are these points. And here we have 0 comma negative 1. Now it turns out the coordinates on the unit circle meaning x and y are the sine and cosine of the angle. So what does that mean? Well, if I draw, let's just draw a line. This is all relative to the positive x-axis. If I draw a line not equal to the positive x-axis, but I draw a line, and the line between, or the angle between the horizontal positive axis and the given line results in this angle theta. And this length is 1, and then the arc length here is, call it S. So that's the arc length. So theta is the ratio of the arc length divided by the radius. So if we have a full circle, S is 2 pi. So 2 pi divided by 1 would give us that a full rotation is 2 pi radians. Now this coordinate of this point here where the unit circle intersects this line that creates this angle is going to have some coordinates, x comma y. And those coordinates are going to be the cosine and the sine. So this actually is the wrong way around. It's cosine comma sine. So the x coordinate is the cosine and the y coordinate is the sine. Now another way you can look at this unit circle is to create a right triangle like that. And this distance here is the x coordinate, and this distance here is the y coordinate, and this distance is 1 because it's a unit circle. So no matter whether you're here, here, anywhere along the circle, you're a distance of 1. So anytime this point moves around the unit circle, you create a new right triangle where the adjacent side is x, the x coordinate, which is the adjacent divided by the hypotenuse is the cosine. So that's two things. One is the coordinates of the point on the unit circle associated with the intersection of positive x-axis and a line that creates an angle. The coordinates are the cosine of the angle and the sine of the angle. Also, you can create this right triangle where the hypotenuse is always 1 and x and y vary depending upon this angle. Okay, so what's the point? The point is that the coordinates on the unit circle are the cosine and the sine. And so we have these values, x, these are the x values, and these are the y values that we can fill out on a unit circle. So what we're going to do is we're going to create this unit circle again. So here's our coordinate system. Here's our circle that has a radius of 1. So this again is 1 comma 0. This is negative 1 comma 0. This is 0 comma 1. This is 0 comma negative 1. So from that, just from this, we can say that the sine of 0 degrees is the x-coordinate, 0, and the cosine of 0 degrees is 1. That's the y-coordinate. So what I'm going to do is I'm going to write that out here. The sine of theta, the angle, is equal to the y-coordinate, and the cosine of theta is equal to the x-coordinate. Let's move those a little bit to the corner here. Okay, so once I've drawn a circle and I have put the coordinates of the intersection of the circle with the coordinate axes and label those, the next thing I can do is I can write the angles associated with the coordinate axes. So the angle here, theta, and I'm going to put degrees and then radians. So up here, theta is 90 degrees, which is pi over 2 radians. Here I have 180 degrees, pi radians. Down here I have 270 degrees, 3 pi over 2 radians. And this all comes, and then if you come all the way around, you get theta is equal to 360 degrees or 2 pi radians. So if we know that a full circle is 360 degrees or 2 pi radians, then half the circle is half of 180 and half of 2 pi. If you go a quarter of the way around, it's a fourth of 360, which is 90, and a fourth of 2 pi, which is pi over 2. Okay. Now, next thing we can do is we can draw lines that bisect between 0 and 90, which is going to be 45. If you take half of 45, 90, you get 45. So we're going to do that next part. So what is the angle here? Theta equals 45 degrees, which is half of 90, and pi over 4, which is half of pi over 2. Now, to get the other points, you can count by 45s, 45, 90. Here, you get 135 degrees. Add 45, you get 180. Add 45, you get 225 degrees. Add 45, you get 270. Add 45, you get 315 degrees. And the same thing applies for here. You're counting by pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So those are the degrees and radians associated with those points. And then you can figure out the coordinates, because we can go back over here. Coordinates are square root of 2 over 2 and the square root of 2 over 2. So I'm going to put the coordinates now. So it's the square root of 2 over 2, square root of 2 over 2. And it makes sense because if I draw a line down here and I'm going to draw a line over there, it's kind of a symmetric thing, and the values should be the same. And let me just do this and I'm going to erase it. If I draw a straight line down, if you think about where a half is, if you go this way and you cut it in half, this is a half. So this value is going to be greater than a half. So we know it's not a half. We know it's greater than a half. And if I go over here and do the same thing, and if I go over horizontally like this, here's a half. You can see how they're the same. They're equal to each other. So that's why they're square root of 2 over 2. Okay, now if we come over here, we can do all of these. Now, we see that these have the same y value. If you draw a horizontal line, you'll see they have the same y value. And if they have the same y value, they have the same x value, except the x value is negative. So we're going to have negative the square root of 2 over 2, positive the square root of 2 over 2 here. The x value is negative, the y value is positive. You come down here, they're both negative. Negative x, negative y. So it's negative the square root of 2 over 2 and negative the square root of 2 over 2. And then over here, x is positive and y is negative. So you get positive the square root of 2 over 2x, negative the square root of 2 over 2y. So you only have to remember square root of 2 over 2, and then you can tell by which quadrant they are in what the sign is. First quadrant, they're both positive. In the second quadrant, x is negative, y is positive. In the third quadrant, they're both negative. Negative x, negative y. In the fourth quadrant, they are positive x, negative y. Okay, then we're going to do the next group, which I guess I'll use red here. So we need to do 30 degrees. Well, if you think about 30, if you took half of 45, you'd be 22 and a half. So 30 has to be somewhere about here. So you go about a third of the way through here, and if you go the other third of the way, you'll get the next one. So use green here. So this angle is going to be 30 degrees. 30 degrees, which is, well, if you take pi over 2 and divide by 3, because you're breaking this up into 3 parts, 30, 60, 90. Take pi over 2 and divide by 3, you'll get pi over 6. And then if you go another 30 degrees, that'll get you to 60 degrees. And if we take 30 is 1 pi over 6, then 60 would be 2 pi over 6, which is 2 over 6 is a third, so you get pi over 3. So this angle is 60 degrees, pi over 3, pi over 6. Now, to find the other corresponding ones in the other quadrants, so we'll do that. Break this up into 3 parts. Break this up into 3 parts. Break this up into 3 parts. Like that. Those are going to have coordinates too. And if you think about it, we can now go all the way around the circle in increments of 1/6. So you have 1/6, 2/6, 3/6, 4/6. Well, let's do the angles first. So you go by 30, 30, 60, 90. So the next one will be 120. The next 120 degrees. You go another 30, you'll get 150 degrees. You go another 30, you have 180. Another 30, you'll have 270. Another 30, you'll have 300. Oh, I did something wrong there. Okay. 180 plus 30 is 210. Then another 30 is 240. Another 30 is 270. Another 30 is 300. Another 30 is 330. Another 30 is 360. So you can see how I can get all those, the angles, by counting by 30. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Now, as far as the other ones, you go 1 6, 2 6, 3 6, 4 6. 4th 6 is 2/3, so you get 2 pi over 3 for this one. So you get, okay, so we go 1 6, 2 6, 3 6, 4 6, 5 6, 5 pi over 6, 6 pi over 6, which is 6 over 6 is 1. Then you get 7 pi over 6. You'll get 8 pi over 6, but 8 over 6 is 4 over 3, so you get 4 pi over 3. So that's, let's go back here. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6. 9 6 is 3/2. 10 6. 10 6 is 5/3, so you get 5 pi over 3. Here we had 10 6, 11 6. 11 pi over 6. So those are the corresponding angles for the increments of 30 degrees. And you see that, you know, when you take the 45s, you go multiples of 45 get you on the coordinate axes. And if you do 30, multiples of 30 get you on the coordinate axis. And then finally, you need to have these are the angles, you need to have the coordinates. So again, we could go back here. The sine of 30 degrees is pi over 2, so that's the y coordinate. The cosine is the x coordinate, square root of 3 over 2. So we can go here, and I'm going to write it in green. So the coordinates are going to be the square root of 3 over 2, a half. And again, you can see if I go to write this down here, you can see that the y coordinate is going to cut that thing right in half, so that's going to be a half. Y coordinate's a half, and the x coordinate is square root of 3 over 2, which turns out to be close to 1. So now to get all the other ones, first we do the 60 degrees. For 60 degrees, all you have to do is switch. So you get a half square root of 3 over 2 for that coordinate. Now, these all have the same y value, and they're also going to have the same x value, except the sign's going to change. So I'm going to write these up here. I know it's getting a little confusing, but so the y value is still positive. The x value becomes negative. So you get negative 1/2 square root of 3 over 2. When you get down here, the x value is square root of 3 over 2, and again, the x value is negative, so it's going to be negative the square root of 3 over 2. The y value is positive, it's going to be a half. And you can do that all the way through here. So here, this one is going to have an x value that's negative, and it's going to be the one closer to 1, and the y value is also negative, negative x, negative y. Coming down here to this point, you have a negative x and negative y. The x value is a half, and the y value is the other thing, and it's negative. So you get negative 1/2, negative the square root of 3 over 2. We come around to 300. Here you can see the y value is still negative, and it's still the square root of 3 over 2. The x value is positive, and it's going to be a half. So we get positive a half, negative the square root of 3 over 2. And then finally here we have a value close to 1 for the x value. So it's going to be positive the square root of 3 over 2, negative 1/2. And there you got it. Okay. So let me just reiterate how we got to this point. And yeah, do I expect you to be able to do this? Well, what I'm going to do is I'm going to show you how you can use this thought process to get the angle or the sines and cosines of these critical angles. I'm not going to rewrite the entire unit circle every time, but I'm going to show you how you can use the unit circle. What I'm going to expect you to be able to do is I'll give you a copy of a unit circle with everything filled out, and you can look up the values from the unit circle. If you go into calculus or something like that, then it might be worth remembering how to do this. Okay, so here's kind of in a nutshell. I'm not going to go into the details, but what we did was we said that the coordinates, well, I guess the first thing we did was we came up with the values of the sine and cosine for 0, 30, 45, 60, and 90. And we did that by drawing first a triangle, right triangle, where two sides were the same. That gave us the hypotenuse was equal to the square root of 2 times, in this case, because I made the two sides 1, the hypotenuse was the square root of 2 using the Pythagorean theorem. Therefore, the sine was equal to the square root of 2 over 2, and the cosine was equal to the square root of 2 over 2. Okay, so that allowed us to fill out this table, these two values. We also talked about how the sine of 0 is 0 and the cosine of 0 is 1, and I mean the sine of 0 is 0 and the cosine of 0 is 1, and they flip around at 90 degrees. So we still had 30 and 60, so what we did there was we took the equilateral triangle, which has equal angles of 60 degrees, and then we cut it in half so that we had a 60, 30, 90 triangle instead of a 60, 60, 60 triangle. And because the equilateral triangle has equal sides as well as equal angles, if we let one side be 1, all of them have to be 1. And if we cut this in half, then this side of this 30, 60, 90 triangle is a half. And then if you use the Pythagorean theorem, you can figure out that the length of the third side is equal to the square root of 3 over 2. And as a consequence, the sine of 60 degrees is the square root of 3 over 2, and the cosine of 60 degrees is a half. And likewise, the sine of 30 degrees is a half, and the cosine of 30 degrees is the square root of 3 over 2. So that allowed us to get these additional ones. The sine of 30, cosine of 30, sine of 60, cosine of 60. We also converted these degrees to radians by saying, 90 degrees is pi over 2, so half of that is pi over 4, 45 is half of 90, pi over 4 is half of pi over 2, and then you can break it up into thirds, so a third of 90 is 60, a third of pi over 2 is pi over 6, and then 60 is twice 30, so you double that, you get 2 pi over 6 or pi over 3. So with that table known, then you can go over here and create this unit circle where you start off first defining the coordinates of the intersection of the unit circle with the coordinate axes, where you get one coordinate is 1 and one coordinate is 0, or -1 and 0. So we get these 4 points. Then you take the 90 degrees and cut it in half, which is 45 degrees, and we can then fill out the unit circle based on this information here in the 45 degree column. And then you can break it up into thirds. So a third of 90 is 30, and twice 30 is 60. And you can see that I can go all the way around this circle in increments of 45 to get all the way around, or I can go start at 30 and go in increments of 30, and twice 45 is 90, 3 times 30 is 90, so these multiples also correspond. Multiples of 45 correspond to the coordinate axes, and multiples of 30 correspond to the coordinate axes. And then once you've defined the angles between 0 and 360, or 0 and 2 pi, you can go back and put the coordinates in. And the only coordinates you have to remember are pi half, square root of 3 over 2, square root of 2 over 2, and square root of 2 over 2, and square root of 3 over 2 and a half. And you can, all you have to do is figure out, whether the x and y are positive or negative. So in the first quadrant, they're both positive. In the second quadrant, they are, the x coordinate is negative and the y coordinate is positive. In the third quadrant, they're both negative, and in the fourth quadrant, x is positive and y is negative. Now, to remember that sign situation, there's this thing that says all students take calculus. Obviously, that's not true, but you take the first letters, A, S, T, C. All students take calculus. And what that's telling you is, in the different quadrants, it's telling you which trig functions are positive. So what this says is, this is the first quadrant. We'll call that Q1. The next one is second quadrant. This is third quadrant. Fourth quadrant. And what we have is we have the sine, we have the cosine, and we have the tangent. So this is Q1, Q2, quadrant 3, quadrant 4. And what it says is that, what are the signs, meaning plus or minus, for these different trig functions? Well, they all are positive in the first quadrant. So A stands for all. In the second quadrant, the sine is positive. In the third quadrant, the tangent's positive. And in the fourth quadrant, the cosine's positive. Now, they either have to be positive or negative. So this tells you that they're positive in which quadrant. So the ones that, when they're not positive, they have to be negative. So you have that. Now, if you count the possibilities here, we have 4 quadrants, and 3 trig functions. So there's 12 possibilities. And you see 1, 2, 3, 4, 5, 6. There's 6 cases where they are positive and 6 cases where they're negative, which you'd expect from symmetry. Another thing you can think about is the tangent is the sine divided by the cosine. So if they're both positive or both negative, if two positives make a positive, 2 negatives make a positive, if they're different signs, one's positive and one's negative, the result has to be a negative. So here, positive divided by negative is negative, and negative divided by positive is negative. So there are different ways you can kind of remember these signs. So some people, instead of thinking about what quadrants these are in, they just remember this thing, all students take calculus. They're all positive in the first quadrant, the sine's positive in the second quadrant, but the cosine and tangent are negative. Third quadrant, the sine and cosine are negative, but the tangent is positive. Fourth quadrant, the cosine is positive, but the sine and tangent are negative. Okay, that's it for unit circles.